Hello, in this lecture we will find the area of the green shape. In the drawing we have triangle ABC. We know that angle BAC, this angle is equal to 60 degrees, and we also know that BF equals to CF equals to DF and equals to EF. So all those four line segments are equal to each other. And also we know that triangle BDF is equal to 8 square units in its area. The area of triangle BDF is 8 square units, and the area of triangle EFC equals to 15 square units. And we want to find out the area of the green shape, or the area of quadrilateral ADEF. Okay, so first of all we will define angle ABC as B, and we will also define angle ACB, this angle is C, and we know that the sum of the angles in any triangle is equal to 180 degrees. Therefore, in triangle ABC, 60 degrees plus B plus C must be equal to 180 degrees. Okay, 60 degrees plus angle B plus angle C must be equal to 180 degrees. So here we will subtract 60 degrees from this equality, and we will get that B plus C equals to 180 degrees minus 60 degrees is 120 degrees. Okay. Question number 1 states that B plus C equals to 120 degrees. Then we have a rule. I will call it rule number 1. Rule number 1 states that in front of equal sides in the triangle, there are equal angles. So I will read rule number 1 again. Rule number 1 states that in front of equal sides in the triangle there are equal angles. So actually, if you focus on triangle BDF, this triangle, we know it is given us in the question that BF equals to DF, and in front of side BF we have angle BDF, and in front of side DF we have angle B. So according to rule number 1, those two angles that are located in front of equal sides are also equal between them. That is to say, if this angle equals to B, then this angle must be also equal to B, because those two angles are equal to each other. Those two angles are equal to each other. And the same thing is about triangle FEC. We know that FE equals to FC, and in front of side FE we have angle C, while in front of FC we have angle FEC. So those two angles that are located in front of equal sides are also equal between them. Therefore, if this angle is C, this angle must be also equal to C, because those two angles are equal to each other. Okay, in the next step, we will define angle DFB as P, and we will define angle EFC, this angle, as Q. And if you focus on triangle BDF, we know that the sum of the angles in triangle BDF equals to 180 degrees. That is to say, angle B plus angle B plus angle F must be equal to 180 degrees. Okay, so 2B plus P must be equal to 180 degrees. We subtract 2B from this equality, and we will get that P equals to 180 degrees minus 2B. Okay, and in triangle EFC, the sum of the angles equals to 120 degrees. Therefore, C plus Q must be equal to 180 degrees. Okay, so 2C plus Q must be equal to 180 degrees. 2C plus Q must be equal to 180 degrees. We will subtract 2C from this equality, and we will get that Q equals to 180 degrees minus 2C. Okay, Q equals to 180 degrees minus 2C. We have already found out that P equals to 180 degrees minus 2B. Okay, so here we will add Q to P. So Q plus P, that is equation number 2. Q plus P will be equal to 180 degrees plus 180 degrees is 360 degrees, and minus 2C plus minus 2B is minus 2C minus 2B. So here we will take a common factor minus 2 from this expression, and we will get that Q plus P equals to 360 degrees minus 2, and in the brackets we will have B plus C. Okay, but we have already found out that B plus C, according to equation number 1, equals to 120 degrees. So we can substitute B plus C in equation number 2 by 120 degrees. Okay, we will get that Q plus P equals to 360 degrees minus 2 times B plus C is 120 degrees, or Q plus P equals to 360 degrees minus 2 times 120 degrees is 240 degrees. So in total we will get that Q plus P equals to 360 degrees minus 240 degrees equals to 120 degrees. And we have already found out that B plus C equals to 120 degrees. Okay, so we have those two equations that Q plus P equals to 120 degrees and P plus C also equals to 120 degrees. Okay, so in the next step we'll find out the size of angle DFB, the size of this angle DFE, the size of angle DFE according to rule number 2. Rule number 2 states that the sum of the angles on a straight line is equal to 180 degrees. I will read rule number 2 again. Rule number 2 states that the sum of the angles on a straight line is equal to 180 degrees. Okay, so we know that BC is one of triangles ABC sides. BC is one side of triangle ABC, therefore BC is a straight line. So the sum of the angles at point F on the straight line BC must be equal to 180 degrees according to rule number 2. So we can write down that P plus Q plus angle DFE must be equal to 180 degrees according to rule number 2. Okay, according to rule number 2, P plus Q plus the size of angle DFE must be equal to 180 degrees according to the rule that the sum of the angles on a straight line BC equals to 180 degrees. So we know that P plus Q equals to 120 degrees, so we can substitute P plus Q by 120 degrees. Okay, so we get that 120 degrees plus angle DFE equals to 180 degrees. Here we subtract from this equality 120 degrees and we will get that angle DFE equals to 180 degrees minus 120 degrees is 60 degrees. Okay, so actually angle DFE equals to 60 degrees. Okay, in the next step we will join together points D and E by a straight line. Okay, and we focus on triangle DFE. In triangle DFE, the green triangle, we know that DF equals to EF. It is given us in the question that DF equals to EF. Therefore, according to rule number 1, in front of equal sides there are equal angles. In front of FE we have angle FDE, and in front of DF we have angle FED. So those two angles that are located in front of equal sides are also equal to each other. So if this angle equals to Y, then the other angle must be also equal to Y, because those two angles are equal to each other. And we know that the sum of the angles in any triangle, and especially in triangle DFE, must be equal to 180 degrees. That is to say, Y plus 60 degrees must be equal to 180 degrees, or 2Y plus 60 degrees must be equal to 180 degrees. Again, in triangle DFE, the sum of the angles must be equal to 180 degrees. That is to say, 2Y plus 60 degrees must be equal to 180 degrees. Here we will subtract 60 degrees from this equality, and we will get that 2Y equals to 180 degrees minus 60 degrees equals to 120 degrees. Here we will divide this equality by 2, and we will get that angle Y equals to 60 degrees. Okay, so the size of angle Y is 60 degrees. Here Y equals to 60 degrees, and also here Y equals to 60 degrees. Okay, so we have triangle DFE is an equilateral triangle because all of its angles are equal to 60 degrees. We know that in an equilateral triangle all the sides are equal to each other. So side DE equals to side FE equals to side DF. All the sides that I marked with two lines like that are equal to each other. So if BF equals to X, then FC also equals to X, and DF also equals to X, and FE also equals to X, and DE also equals to X. Okay? In the next step we will find out the size of angle ADE and the size of angle AED, the size of this angle. According to the rule that the sum of the angles on a straight line is equal to 180 degrees. Actually, AB is one of the sides of triangle ABC, therefore it is a straight line. And we know that the sum of the angles on a straight line is equal to 180 degrees according to rule number 2. So if we focus at point D on the straight line AB, the sum of the angles must be equal to 180 degrees. That is to say, B plus 60 degrees plus angle ADE, this angle, must be equal to 180 degrees according to rule number 2. Okay, angle B plus 60 degrees plus angle ADE must be equal to 180 degrees according to rule number 2. Here we will subtract 60 degrees and also B from this equality, and we will get that angle ADE equals to 180 degrees minus 60 degrees is 120 degrees minus B. Okay, but we have already found out in equation number 1 that b plus c equals to 120 degrees. Okay, we will subtract b from this equation number 1 and we will get that angle C equals to 120 degrees minus b. Okay, so here 120 degrees minus b equals to C according to equation number 1. So actually from this equality we can derive that angle ADE equals to C. Okay, angle ADE equals to C. So here angle ADE equals to C. We will repeat on the same process on the other side of triangle ABC. Again, we know that AC is one of the sides of triangle ABC, therefore it is a straight line. And we know that according to rule number 2, the sum of the angles on a straight line is equal to 180 degrees. Therefore, we focus at point E on straight line AC. The sum of the angles must be equal to 180 degrees. That is to say, C plus 60 degrees plus angle AED. This angle must be equal to 180 degrees, again according to rule number 2. Again, angle C plus 60 degrees plus angle AED must be equal to 180 degrees according to rule number 2. Here we will subtract 60 degrees and C from this equality and we will get that angle AED equals to 180 degrees minus 60 degrees is 120 degrees minus C. Okay, but we have already found out in equation number 1 that B plus C equals to 120 degrees. Okay, so here we will subtract from equation number 1 B, and we will get that C equals to 120 degrees minus B. C equals to 120 degrees minus B. So here actually we will subtract C from equation number 1 and we will get that B, if we subtract C from equation number 1, we will get that B equals to 120 degrees minus C. Okay, B equals to 120 degrees minus C. So here 120 degrees minus C equals to B according to equation number 1. Again, here 120 degrees minus C, 120 degrees minus C equals to B according to equation number 1. 100 degrees minus C equals to B according to equation number 1. So from this equality, we can derive that angle AED equals to B. Okay, angle AED equals to B. So here angle AED, this angle equals to B. Okay, so we found out that in triangle ADE we have angles 60 degrees B and C, and actually we have the same angles in triangle ABC, 60 degrees B and C. So we will compare, or we will focus on triangles ABC and ADE. Okay, so we will focus on triangles ABC and triangle ADE. Okay, we focus on triangle ADE and on the big triangle ABC. Angle AED on triangle ADE equals to angle ABC on triangle ABC. And those two angles are both equal to B. Okay? And angle ACE on triangle ADE equals to angle ACB on triangle ABC. And both those two angles are equal to C. Okay? So we found out that we have two angles that are equal in both those two triangles. And the third angle, this angle A is a common angle. It actually belongs to triangle ADE, and angle A that equals to 60 degrees belongs also to triangle ABC. So we can write down that angle A equals to angle A. Actually, it is a common angle. It belongs to both triangles. Okay, so we actually proved that all the angles in triangle ADE are congruent to all the angles in triangle ABC. Therefore, we actually proved that the small triangle ADE is similar to the big triangle ABC. According to angle similarity rule. We read again the picture around. Triangle ADE, the small green triangle, and the small green triangle is similar to triangle ABC according to angle similarity rule. So angle similarity rule is a rule that states that if you prove that all the angles in one triangle are congruent to all the angles of another triangle, then those triangles are similar to each other according to angle similarity rule. Okay, so triangle ADE is similar, this triangle is similar to the big triangle ABC, and we actually have rule number 3 that relates to similar triangles. Okay. Rule number 3 states that the ratio between the areas of similar triangles is equal to the square ratio of the corresponding sides. I will read rule number 3 again. Rule number 3 states that the ratio between the areas of similar triangles is equal to the square ratio of the corresponding sides. Okay, so actually, according to rule number 3, if we divide the area of triangle ABC that is the sine of the area of triangle ABC. So if we divide the area of triangle ABC by the area of triangle ADE, it will be, this ratio will be equal to the ratio between the corresponding sides. That is to say, it will be equal to BC square over DE square. Okay? So actually that is the meaning of rule number 3, that the ratio between the areas of triangle ABC and triangle ADE equals to the square ratio of the corresponding side. So the area of triangle ABC over the area of triangle ADE equals to BC square over DE square. But what is the value of BC? BC equals to x plus x, that is to say BC equals to 2x. So BC square will be equal to 2x square over DE square. DE equals to x, so DE square is x squared. So 2x squared is 4x squared. 4x squared over x squared is equal to 4. So the area of triangle ABC over the area of triangle ADE equals to 4. Okay? So here, if we multiply this equality by the area of triangle ADE, we will get that the area of triangle ABC equals to 4 times the area of triangle ADE. Okay, the area of triangle ABC equals to 4 times the area of triangle ADE. Okay? But what is the area of quadrilateral BDEC? What is the area of this quadrilateral? The area of quadrilateral BDEC will be equal to the area of triangle ABC minus the area of triangle ADE. The area of triangle ABC minus the area of triangle ADE. Again, the area of quadrilateral DBEC will be equal to the area of the big triangle, triangle ABC, minus the area of the small triangle, triangle ADE. Okay? Again, the area of quadrilateral PDEC equals to the area of the big triangle, triangle ABC, minus the area of the small green triangle, triangle ADE. But we have already found out that the area of triangle ABC equals to 4 times the area of triangle ADE, so we can substitute the area of triangle ABC by 4 times the area of triangle ADE. Okay, we get that the area of quadrilateral BDEC equals to 4 times the area of triangle ADE minus the area of triangle ADE. So actually here 4 times the area of triangle ADE minus 1 times the area of triangle ADE equals to 3 times the area of triangle ADE, and it is equal to the area of quadrilateral BDEC. So actually we found out that the area of quadrilateral BDEC equals to 3 times the area of triangle ADE, and we've already found out that the area of triangle ABC equals to 4 times the area of triangle ADE. Okay? And in the next step I will present to you a new formula for the area of any triangle. So if we have a triangle ABC, and we know that side AB of triangle ABC equals to A units, side AC of triangle ABC equals to B units, and the angle between side AB and side AC is theta, then the area of this triangle, triangle ABC, equals to A times B times sine theta over 2. Okay, that is the area of triangle ABC. Again, the area of this triangle according to the new formula is equals to A times B times sine theta over 2. Okay, so we use this formula in order to calculate the areas of the big triangle, triangle EFT, and the area of the small triangle, triangle DBF. So actually if we divide the areas of those two triangles, we will get that 15 over 8, 15 square meter over 8 square meter equals to, okay, so we get that 15 over 8, so 15 is the area of the big triangle, and the formula for the area, according to the formula that I presented to you, to the area of any triangle, the area of triangle EFC, this triangle will be equal to EF times FC times sine Q over 2. Again, the area of the big triangle EFC equals to EF times FC times sine Q over 2. And we divide it by the area of the small triangle. So, what is the area of the small triangle? The area of the small triangle equals to DF times BF times sine P over 2. Okay. Again, the area of the small triangle BDBF equals to DF times BF times sine P over 2. DF times BF times sine P over 2. So here we will move these two to the numerator and this expression to the denominator of this equality. So we will get that 15 over 8 equals to 2 times EF times FC times sine Q over 2 times DF times VF times sine P. So we got this equality. Here 2 over 2 is 1, so 2 is cancelled. And what is the value of EF? EF equals to X and FC also equals to X, so EF times FC is X times X, that is X squared times sine Q over DF is X times BF is also X, so X times X is X squared times sine P. So in total we got that 15 over 8 equals to X squared sine Q over X squared times sine P. Here X squared times X squared is 1, so X squared is cancelled. So in total we got that sine Q over sine P equals to 15 over 8. Okay, so we got this trigonometric this equality that sine Q over sine P equals to 15 over 8. But we have already found out that Q plus P, in question number 2, that Q plus P equals to 120 degrees. Okay, Q plus P equals to 120 degrees. Here we will subtract from question number 2 P, and we will get that Q equals to 120 degrees minus P. Okay, we got that Q equals to 120 degrees minus P. So we can substitute Q in this equality by 120 degrees minus P. So we'll do it now. Instead of sine Q, we write down sine 120 degrees minus P, that equals to Q, over sine P equals to 15 over 8. Okay, we got this equality. So actually, in order to find out the value of sine 120 degrees minus P, I will present to you a new trigonometric identity for sine A minus B. Sine A minus B equals to sine A times cosine B minus sine B times cosine A. Okay, so actually we will use this trigonometric identity in order to find out the value of sine 120 degrees minus P. Sine A minus B equals to sine A times cosine B minus sine B times cosine A. According to this trigonometric identity, the value of sine 120 degrees minus P will be equal to sine 120 degrees times cosine P minus sine P times cosine 120 degrees. Okay, so we calculated the value of sine 120 degrees minus P according to this trigonometric identity. So here we will get that sine 120 degrees is root 3 over 2 times cosine P minus sine P times cosine 120 degrees is minus 1 over 2, and here we have minus times minus is plus, so in total we will get that it equals to root 3 over 2 times cosine P minus minus and minus is plus, so it is plus 1 over 2 sine P. Okay, so we found out the value of sine 120 degrees minus P. The value of sine 120 degrees minus P equals to root 3 over 2 times cosine P plus 1 over 2 times sine P. So actually we have the original equality that states that sine 120 degrees minus P over sine P equals to 15 over 8. So in this trigonometric identity, we will substitute sine 120 degrees minus P by this expression that equals to sine 120 degrees minus P. So we will get that instead of sine 120 degrees minus P, we will write down that root 3 over 2 times cosine P over sine P plus 1 over 2 times sine p over sine p equals to 15 over 8. Okay, so in total we got that root 3 over 2 times cosine p over sine p plus 1 over 2 times sine p over sine p is 1, so sine p is cancelled, and cosine p over sine p is cotangent p, so I write it down, root 3 over 2 cosine p over sine p is cotangent p plus 1 over 2 is 4 over 8 equals to 15 over 8. Here cotangent p, we have trigonometric identity that says that cotangent p equals to 1 over tangent p we use this trigonometric identity. Actually we'll substitute cotangent p in this equality by 1 over tangent p. We'll get that root 3 over 2 times, instead of cotangent p we write down 1 over tangent p, 2 times tangent p, and plus 4 over 8 equals to 15 over 8. Here we'll subtract 1 over 8 from this equality, and we will get that root 3 over 2 times tangent p we subtracted 4 over 8 from this equality, so it will be equal to 15 over 4 over 8 minus 4 over 8 is 0, and 15 over 8 minus 4 over 8 is 11 over 8. So in total we got that root 3 over 2 times tangent p equals to 11 over 8. Here we will multiply this equality by tangent p. We will get that 11 over 8 times tangent p equals to root 3 over 2. Here we will multiply this equality by 8, and then we will divide it by 11 in order to get the value of tangent p. We will get that tangent p equals to root 3 over 2 times 8 over 11. So here 8 over 2 is 4. Okay, 8 over 2 is 4. So in total we got that tangent p equals to 4 times root 3 over 11. Okay, tangent p equals to 4 times root 3 over 11. Actually, the function tangent p it expresses the relationship between the sides in a right triangle. So this specific function tangent p equals to 4 times root 3 over 4, it is actually can be expressed by drawing a right triangle So in this right triangle, we know that this is angle P. This side equals to 4 times root 3 and this side equals to 11. So here tangent P equals to 4 times root 3 over 11. So this drawing expresses actually exactly this equality, that tangent P equals to 4 times root 3 over 11. So in order to find out the hypotenuse of this right triangle, we'll use the Pythagorean theorem that says that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The sum of the squares of the perpendiculars, it is actually 11 square plus 4 times root 3 square. So actually this expression is the square of the hypotenuse, but we want to find out the hypotenuse itself, not the square of the hypotenuse. So if we take a root out of the square of the hypotenuse, we will get the hypotenuse itself. So the square of this expression equals to the hypotenuse itself. So here the value of sine P will be equal to 4 times root 3 over the hypotenuse. But what is the value of the hypotenuse? 11 square is 121 plus 4 times root 3 square is 48. 121 plus 38 is 169, and the root of 169 is 13. So the hypotenuse equals to 13 and sinus P equals to 4 times root 3 over 13. So we found out that sine P equals to 4 times root 3 over 13. But what is the area of triangle DBF? The area of triangle DBF equals to x times sinus P over 2. The area of triangle DBF equals to x times x is x squared times sine P over 2. But we know that the area equals to 8 square units. Okay? So we found out that the area of triangle DBF equals to x squared times sine P over 2, and we know that the area equals to 8 square units. But we have already found out the value of sine P. Sine P equals to 4 times root 3 over 13, so we can substitute sine P in this equality by 4 times root 3 over 13. We'll get that x squared over 2 times sine P equals to 4 times root 3 over 13, all equals to 8. So here 4 over 2 is 2. Over 2 is 2. So we get that 2x squared times root 3 over 13 equals to 8. Here we will divide this equality by 2, and we will get that x squared times root 3 over 13 equals to 4. So we got that x squared times root 3 over 13 equals to 4. Here we will multiply this equality by 13 and then we will divide it by root 3 in order to get the value of x squared. We will get that x squared equals to 13 times 4 is 52. 52 over root 3 is the value of x squared. X squared equals to 52 over root 3. In the next step we'll find out the area of the equilateral triangle, triangle DFE. So the area of the equilateral triangle, triangle DFE will be equal to x times sine 60 over 2. X times x is x squared, and sine 60 degrees is root 3 over 2. But we have sine 60 degrees over 2, so it is root 3 over 2 over 2. Root 3 over 2 over 2 is actually root 3 over 4. So actually we found out that the area of the equilateral triangle, triangle DFE equals to x squared times root 3 over 4. But we have already found out that x squared equals to 52 over root 3, so we can substitute x squared in this equality by 52 over root 3. And we will get that the area of triangle DFE equals to x squared is 52 over root 3 times root 3 over 4. So here we have root 3 over root 3 is 1, so root 3 is cancelled, and 52 over 4 is 13. So we found out that the area of the equilateral triangle, triangle DFE equals to 13 square units. Okay? So actually the area of equilateral triangle, triangle DFE equals to 13 square units. So after we found out the area of the equilateral triangle, we can find out the area of quadrilateral DBEC. The area of quadrilateral DBEC equals to the area of triangle DBF, that is 8 square units, plus the area of the equilateral triangle, that is 13 square units, plus the area of the big triangle EFC, that is 15 square units. So in total the area of the equilateral triangle and the area of quadrilateral DBEC equals to 8 plus 13 is 21, and 21 plus 15 is 36. So the area of quadrilateral DBEC equals to 36 square units. Okay, the area of quadrilateral DBEC equals to 36 square units. But we have already found out that the area of quadrilateral DBEC equals to 3 times the area of triangle ADE. Okay? So from this equality we can derive that 3 times the area of triangle ADE equals to 36 square units. Okay, 3 times the area of triangle ADE equals to 36 square units. Here we can divide this equality by 3 and we will get that the area of triangle ADE equals to 36 over 3 is 12 square units. Okay, so we found out that the area of triangle ADE, the area of this triangle, triangle ADE, equals to 12 square units. So therefore the area of the green shape, or the area of quadrilateral ADFE EF is actually equals to the area of triangle ADE, that is 12 square units, plus the area of the equilateral triangle, triangle DFE, that is 13 square units, or 12 plus 13 is 25 square units. So the area of quadrilateral ADEF equals to 25 square units. Okay, so we actually found out that the area of the quadrilateral ADEF equals to 25 square units, so the area of the green shape equals, this green shape equals to 25 square units. Okay, so now I'll summarize the lecture. Actually, we wanted to find out the area of the green shape or the area of quadrilateral ADEF. We know that in triangle ABC, angle BSC equals to 60 degrees. And we also know that BF equals to CF equals to DF equals to EF. And we also know that the area of triangle DBF, this triangle, equals to 8 square units, and the area of triangle EFC equals to 15 square units. And we want to find out the area of quadrilateral, the green shape for the green quadrilateral ADEF. Okay, so actually we defined angle ABC as B and angle ACB as C, and we know that the sum of the angles in any triangle equals to 180 degrees, and especially the sum of the angles in triangle ABC equals to 180 degrees. Therefore, we can write down that 60 degrees plus B plus C must be equal to 180 degrees. We subtracted 60 degrees from this equality, and we got that B plus C equals to 120 degrees. And then we have rule number 1 that states that in front of equal sides in the triangle there are equal angles. So actually, if we focus on triangle DBF, we know that DF equals to BF, and in front of DF we have angle B, so in front of BF we have angle BDF. So those two angles that are located in front of equal sides must be equal to each other according to rule number 1. Therefore, if this angle is B, this angle also must be equal to B. Okay, and the same thing in triangle FEC. We know that FE equals to FC, it is given us the question, and in front of FE we have angle C, in front of FC we have angle FEC. So those two angles that are located in front of equal sides in the triangle must be equal to each other according to rule number 1. So if this angle is C, this angle must be also equal to C. Okay, and then in the next step we defined angle DFB as P and angle EFC as Q. And so in this triangle BDF, the sum of the angles must be equal to 180 degrees. That is to say, B plus B plus P must be equal to 180 degrees, or 2B plus P in triangle DBF must be equal to 180 degrees. We subtracted 2B from this equality and we got that P equals to 180 degrees minus B. And the same thing is true in triangle FEC. The sum of the angles in triangle FEC must be equal to 180 degrees. So C plus Q must be equal to 180 degrees. Or 2C plus Q equals to 180 degrees. We subtracted 2C from this equality and we got that Q equals to 180 degrees minus 2C, and we've already found out that P also equals to 180 degrees minus 2B. So we added Q to P. So Q plus P equals to 180 degrees plus 180 degrees is 360 degrees. And minus 2C plus minus 2B is minus 2C minus 2B. Here we took a common factor minus 2 out of this expression, and we got that Q plus P equals to 360 degrees minus 2 times B plus C. But we know that B plus C equals to 120 degrees according to equation number 1, so we can substitute B plus C in equation number 2 by 120 degrees. Okay, so substitute B plus C by 120 degrees in equation number 2, and we got that Q plus P equals to 360 degrees minus 2 times 120 degrees. And after solving this equation number 2, we found out that Q plus P equals to 120 degrees, and we also found, we have already found out that B plus C also equals to 120 degrees. Then we have rule number 2 that states that the sum of the angles on a straight line is equal to 180 degrees. Okay, we use rule number 2 in order to find out the value of this angle DFE. So BC is a straight line because it is one of the sides of triangle ABC. Therefore BC is a straight line. So on the straight line BC at point F, the sum of the angles is equal to 180 degrees. So that is to say, P plus Q plus angle DFE must be equal to 180 degrees according to rule number 2. P plus Q plus angle DFE must be equal to 180 degrees according to rule number 2. And we have already found out that P plus Q equals to 120 degrees, so we can substitute P plus Q in this equality by 120 degrees. So we substitute P plus Q by 120 degrees. We got this equality. We subtracted 120 degrees from this equality, and we got that angle DFE equals to 60 degrees. So this angle DFE equals to 60 degrees. And then we connected together points D and E by a straight line, and then in this way we created triangle DFE. In triangle DFE, we know that DF equals to EF. It is given us in the question. We know that DF equals to EF. So according to rule number 1, in front of equal sides there are equal angles. So those two angles are located in front of equal sides. Therefore they are equal to each other. So if one angle is y, then if this angle is y, then the other angle must be also equal to y, because those two angles are equal to each other. Okay? So in triangle DFE, we know that the sum of the angles are equals to 180 degrees. So angle y plus 60 degrees must be equal to 180 degrees, or 2y plus 60 degrees must be equal to 120 degrees. We subtracted 60 degrees from this equality, and we got that 2y equals to 120 20 degrees. We divided this equality by 2 and we got that y equals to 60 degrees. So this angle is 60 degrees and this angle is also 60 degrees. Therefore, triangle DFE, this green triangle, is an equilateral triangle. All the sides are equal to each other. So if one side is x, the other side are also x, and BF also x, and FC also x, because all the sides are equal to each other according to what is given us in the question. Okay. Then we found out the values of the sizes of those two angles. According to rule number 2, that states that the sum of the angles on a straight line, the sum of the angles on a straight line is equal to 180 degrees. So here we know that AB is a straight line, therefore B plus 60 degrees plus the size of angle ADE must be equal to 180 degrees according to rule number 2. Okay, again, angle B plus 60 degrees plus angle AD must be equal to 180 degrees according to rule number 2. We subtracted B and 60 degrees from this equality and we got that angle AD equals to 120 degrees minus B. But we know that B plus C equals to 120 degrees. Here we subtracted B from this equality and we got that C equals to 120 degrees minus B. So here 120 degrees minus B equals to C according to equation number 1. So from this equality we can derive that angle ADE equals to C. Okay, angle ADE, this angle equals to C. We repeated on the same process on the other side of triangle ABC. We know that AC is a straight line, therefore C plus 60 degrees plus angle AED must be equal to 180 degrees according to rule number 2. C plus 60 degrees plus angle AED must be equal to 180 degrees according to rule number 2. Then we subtracted C and 60 degrees from this equality and we got that angle ADE equals to 120 degrees minus C. But we have already found out that B plus C equals to 120 degrees. We subtracted B from this equality, equation number 1, and we got that C equals to 120 degrees minus B. So here 120 degrees, so here actually we subtracted C from equation number 1, and we got that B equals to 120 degrees minus C. So here 120 degrees minus C according to equation number 1 equals to B. Okay, so from this equality we derive that angle AED equals to B. Angle AED, this angle equals to B. Then we focused on triangle ADE and on triangle ABC. We know that angle AED equals to angle ABC, and both those two angles are equal to each other. We also know that angle ADE equals to angle ACB in triangle ABC, and both those two angles are equal to each other. And we also know that this angle that equals to 60 degrees is a common angle. It belongs both to the small triangle, big triangle ADE, and angle A also belongs to the big triangle, triangle ABC. So angle A equals to angle A, it is a common angle. So we actually proved that all the angles on the small green triangle of triangle ADE are equal or congruent to all the angles on the big triangle, triangle ABC. Therefore we proved that triangle ADE is similar to triangle ABC according to angle similarity rule. Then we have rule number 3 that states that the ratio between the areas of similar triangles is equal to the square ratio of the corresponding sides. So actually, rule number 3 means that the area of triangle ABC over the area of triangle ADE equals to BC square over DE square. and BC equals to 2x, DE equals to x, so BC square over DE square equals to 2x square over x square is actually 4, so the area of triangle ABC over the area of triangle ADE equals to 4. Okay? And if we multiply this equality by the area of triangle ADE, we will get that the area of triangle ABC equals to 4 times the area of triangle ADE. Then we found out the area of quadrilateral DBEC. The area of quadrilateral DBEC equals to the area of triangle ABC minus the area of triangle ADE. Okay, the area of quadrilateral DBEC equals to the area of triangle ABC minus the area of triangle ADE. But we have already found out that the area of triangle ABC equals to 4 times the area of triangle ADE. So we can substitute the area of triangle ABC by 4 times the area of triangle ADE because they are equal to each other. Okay, and we will get that the area of quadrilateral BDEC equals to 4 times the area of triangle ADE minus 1 times the area of triangle ADE, that is 3 times the area of triangle ADE. So the area of quadrilateral BDEC equals to 3 times the area of triangle ADE. And then I presented to you a new formula for the area of any triangle. The area of this triangle equals to A times B times sine theta over 2. Again, the area of this triangle equals to A times B times sine theta over 2. Okay, we use this formula in order to find out the areas of those two triangles. We divided the areas of those two triangles by each other. The area of the big triangle over the area of the small triangle is 15 over 8, and the area of the big triangle, according to the formula that I presented to you, equals to EF times FC times sine Q over 2. EF times FC times sine Q over 2 according to the formula that I presented to you. And the area of the small triangle, triangle DBF, equals to DB equals to DF times BF times sine P over 2. DF times BF times sine P over 2. Okay, then here 2 is cancelled, and we got that x squared times sine Q over x squared times sine P equals to 15 over 8. X squared, here x squared is cancelled, and we found out that sine Q over sine P equals to 15 over 8. But we already know that Q plus P equals to 120 degrees, according to equation number 2. So from this equation, we will get that Q equals to 120 degrees minus P, and we substituted Q by 120 degrees minus P because Q equals to 120 degrees minus P. So we got that sine 120 degrees minus P over sine P equals to 15 over 8. Then I presented to you the trigonometric identity sine A minus B in order to find out the value of sine 120 degrees minus P. So sine A minus B equals to sine A times cosine B minus sine B times cosine A. We use this trigonometric identity in order to find out the value of sine 120 degrees minus P, and we found out that the value of sine 120 degrees minus P equals to 3 over 2 times cosine P plus 1 over 2 times sine P. So we substituted sine 120 degrees minus P in this equality by this expression that equals to sine 120 degrees minus P. Here we have this equality. We substituted sine 120 degrees minus P by this expression that equals to sine 120 degrees minus P, and we got that tangent P equals to 4 times root 3 over 4. From this we found out from this equality we found out that sine P equals to 4 times root 3 over 13. Okay, so sine P equals to 4 times root 3 over 13, and the area of triangle BDF equals to x times sine P over 2, and we know that the area of triangle DBF equals to 8, so x squared times sine p over 2 equals to 8. And we have already found out that sine p equals to 4 times root 3 over 13, so we can substitute sine p by 4 times root 3 over 13. Okay, so we substituted sine p by 4 times root 3 over 13, and we found out that x squared equals to 52 over root 13. Okay, then we found the area of triangle DEF, the equilateral triangle DEF, actually it equals to x squared times root 3 over 4. But we already found out that x squared equals to 52 over root 3, so we can substitute x squared in this equality by 52 over root 3. Okay? And we found out that the area of the equilateral triangle DFE equals to 13 square units. So in this way we found out also the area of quadrilateral DBEC that equals to the area of triangle DBF plus the area of triangle DFE plus the area of triangle EFC, that in total the areas of these three triangles equals to 36 square units. But we have already know that 3 times the area of triangle AD equals to the quadrilateral DBEC. So from this equality we can derive that 3 times the area of triangle AD equals to 36 square units. We divided this equality by 3 and we found out that the area of triangle ADE equals to 12 square units. So the area of quadrilateral DBEC equals to the area of triangle DBE, that is 12 square units, plus the area of triangle DEF, the equilateral triangle DEF, that is 13 square units. So in total, the sum of those the areas of those two triangles equals to the area of quadrilateral ADEF. So it is the area of triangle ADE, that is 12 square units, plus the area of quadrilateral DEF, that is 13 square units. So 12 plus 13 is 25. So the area of quadrilateral ADEF equals to 25 square units. Again, the area of quadrilateral ADEF equals to 25 square units. Okay, thank you very much.